The history of probability is the development of mathematical thinking. How do we calculate probability? Many people think probability is simply about counting cases. In some situations, the calculation is very easy. For example, what is the probability of rolling a 3 on a die? There are 6 possible outcomes, and only one of them is a 3. So, the probability is 1/6. But how do we calculate the probability of getting a pair in poker? Problems like this are much more complex. We must count every possible case accurately. In the end, probability is closely connected to how well we can count possibilities. The French mathematician and astronomer Pierre-Simon Laplace was the first to organize probability into a mathematical system. In 1812, he published The Analytical Theory of Probability, bringing together probability theories that had previously been scattered. How did Laplace define probability? He defined the probability of an event as the number of favorable outcomes divided by the total number of possible outcomes. This is called classical probability or mathematical probability. Most of the probability taught in school is based on this definition. However, this definition has some problems. First, it assumes that all outcomes are equally likely. For example, when we toss a coin, can we really say that heads and tails have exactly the same chance of occurring? In reality, a coin may not be perfectly balanced, and in very rare cases, it may even land on its edge. Second, not all probability problems have a finite number of outcomes. If there are infinitely many outcomes, counting cases alone does not easily define probability. Third, the principle of insufficient reason is not always justified. This principle says that without special information, we should treat all outcomes as equally likely. But if we truly have no information, can we really conclude that all outcomes are equally possible? Because of these issues, mathematicians began seeking a more rigorous definition of probability in the late 19th century. As a result, modern probability theory is based on a few fundamental rules called axioms. First, the probability of any event is between 0 and 1. Second, the probability of the sample space, which contains all possible outcomes, is always 1. In other words, at least one outcome must occur. Third, if 2 events cannot occur at the same time, the probability that either event occurs equals the sum of their probabilities. Even with this mathematical definition of probability, one question remains. We learn that the probability of getting heads when tossing a coin is 1/2. But if we toss a coin twice, will we always get heads exactly once? Probably not. We might get heads both times, or tails both times. Does that mean mathematical probability is different from reality? The answer lies in the law of large numbers. As the number of trials increases, the observed results move closer to the theoretical probability. If we toss a coin 10 times, we might get heads 7 or 8 times. But if we toss it 10,000 times, the proportion of heads gets closer and closer to 1/2. So, a probability of 1/2 does not mean once in every 2 tries. It is closer to saying that after many repetitions, the outcome occurs about half the time on average. A common mistake comes from misunderstanding probability. This is called the gambler's fallacy. If a coin lands heads 4 times in a row, what would be expected next? Another head or a tail because it seems due? Gamblers in the past believed it was time for tails to appear. But a coin toss is an independent event. Previous results do not affect future results. Even if heads appears 4 times in a row, the probability of heads on the 5th toss is still 1/2. This mistake of believing that past results change future outcomes is called the gambler's fallacy. Probability theory has developed over a long period of time and become more sophisticated. As a result, people no longer view the world as simply black and white. Will it rain tomorrow or not? Will we pass the exam or not? Probability does not simply answer yes or no. Instead, it tells us how likely something is. For the same reason, a weather forecast might say, there is a 60% chance of rain. Probability is not the mathematics of predicting the future perfectly. It is the mathematics of calculating future possibilities. This way of thinking helps us consider more possibilities and make wiser choices.